Hello, today we're going to talk about how to calculate the internal rate of return. The calculation of the internal rate of return can be somehow tedious and you need to repeat yourself 100 times to get the right internal rate of return that makes the net present value equals to zero. In order to calculate the IRR or internal rate of return in an easy way that saves us time, we can follow a method called the interpolation method. Interpolation method. And it is driven from the concept of the IRR, as IRR is the discount rate that makes the NPV of a project equals to zero. So, how the NPV can be calculated? NPV equals to initial investments at time zero plus the summation of all future cash flows. Cash flow T over 1 plus R power T, and T goes from 1 to N. So basically, all the future cash flows throughout the life of the project. Okay, so the IRR is the discount rate that we will incorporate in this equation that will make the NPV equals to zero. So how can we calculate the NPV of a project? The idea is quite simple. Now assume we have a project called project X. It has an initial investment of £1,000, and for sure that would be negative, and it will result in cash flows of 500 for year one. So basically this is times 0, and this is 1, 2, 3. Okay, by the end of year one you will get 500s, by the end of year two 500s, by the end of year three 500s as well. So in order to calculate the net present value, we will consider the cost of capital for sure in order to calculate it. So we can assume that the cost of capital R equals to 10%. All right, so we will calculate the present value of these cash flows, the 3 cash inflows, and discount them back to time 0. That is quite simple. So we will go with the calculation. 500 times 1 minus 1 plus 10% power minus 3 divided by 10%. And the present value will be 1,243. We deduct from it the £1,000. So basically, to cut the story short, the net present value will equal to 243.42, given that the R equals to 10%. So if the required rate of return equals to 10%, the net present value equals to £243.42. And we know that the IRR is the discount rate that makes the NPV equals to a negative number. So we try another net present value that will make, the IRR makes the net present value equals to 0. So we will try a larger required rate of return or a larger discount rate in order to make that net present value a smaller number. So we can say, for example, I will try with R equals to 15%. I'm quite sure that it will result in a negative NPV. Okay, so when I calculate the net present value, I think the net present value is not hard to calculate. So it is going to be 141 and 61 pence NPV if the required rate of return equals to 15%. We may give it a trial with 23%. It gives us a positive result, so it is, if it's 23%, it will give us NPV equal to £5.68. So I think if the net present value will be higher than the 23%, it will result in a negative value. If I tried net present value and calculate the discount rate to be 24%, NPV will equal to minus 9.34 pounds. So the net present value becomes negative. So we have here a discount rate that makes the net present value a positive number, and another discount rate that makes the net present value a negative number. So how can we calculate the IRR then? IRR equals to the return, the discount rate or the required rate of return of the positive plus the net present value of the positive divided by the net present value of the positive plus the absolute result of the negative net present value. So it's 9.34 times the difference between the negative required rate of return and the positive required rate of return. So 24% minus 23%. The result will give us the required rate of return. So here we can just delete this and write the R positive, which is 23%, and here as well. So 0.68 plus. It should give us a result in between. So the result is 23.378%. So here is the required rate of return that will make the net present value equals to 0. Thank you so much. And this is for sure the IRR. Thank you so much.